All right, day 2 notes, 5-1. So before we get started at all, let's go ahead and look at this launch. So we're going to recap from what we learned on 5-1 day 1 notes. So go ahead and either translate the phrase into an expression or expression into a phrase. So pause the video in order to answer these 4 quick questions, A through D, and then go ahead and push play to check your answers to see how we did or your understanding from yesterday. Go ahead and pause. All right, so let's take a look. 3 less than. Remember, 3 less than something else means I need to take 3 away from some other term. So my other term is 2x. So that minus 3 has to be at the end. If you have 3 minus that expression, it is incorrect. So make sure that you have it in that specific order. For letter B, I wrote 6 more than. So remember, that's plus 6. The quotient, answer to a division problem, of 5 and a number. Remember, quotient, whatever's listed first, that has to go in the numerator. So 5 goes up in the numerator. And then the next one, C, this one is a little bit more difficult. So I kind of worded a little bit different than we did on the day 1 notes. And I said the product of 2/3 and, which means that it's 2/3 and whatever else I list after it. So whatever else I list after it, that's why in the parentheses, it needs to be the difference of x and 5. So subtracting, and then x is listed first, so therefore that way we have the x minus 5. And then for letter D, I have the quotient of a number and 2. So x divided by 2 increased by 7, so plus 7 more. All right, so now we're going to look at the new material. The first thing that we're going to learn is to define a variable. So we're going to choose a variable to represent an unknown value. So, for example, if I want to say, like, I want to use the variable x, we can just say that this represents the number of shoes, if the shoes is unknown. So I'm just going to write exactly like that. I'm going to say the variable, and then I'm going to use that semicolon, and I'm going to tell exactly what that a variable is going to be represented by. So in translating, I'm going to move this down, translating a variable, or translating a phrase, you first have to define the variable and then translate each phrase into the algebraic expression. So right here, example 1, it says 2 miles less than the athlete ran. So you have to kind of decide, well, what is my unknown? And my unknown is how much the athlete ran. I don't know that. So the athlete ran. I don't know how much they ran, so I'm going to say x represents the number of miles the athlete ran. And notice I didn't just say athlete ran, because you need to show your teacher that you understand what it is that you're trying to designate that variable as. So I don't know how many miles the athlete ran, but I know that I can use a variable to represent that unknown value. So 2 miles less than the athlete ran, we've learned already from day 1 that 2 miles less than, which means that I'm taking 2 miles away from some other term or some other number. So 2 miles less than has to go at the end, which means that there's something that goes before it, and it says than the athlete ran, and we know that's our unknown, and we use that variable x, so therefore our answer is x minus 2. And no, you don't necessarily need this subtraction sign or this blank. I was just showing you that I needed to put that 2 miles at the end. So there's the number of miles the athlete ran, and then I'm taking away 2, because that's what 2 miles less than represents. All right, example 2. 5 points more than the points scored by field goals if each field goal is worth 3 points. So in this situation, 5 points more than, okay, so 5 points more than, which means that I know that my plus 5 is going to go at the end, right? So I'm just going to put that over there for now. The points scored by field goals, if each field goal is worth 3 points. So I know how much each one is worth, but my unknown is how many actual field goals are kicked, right? We don't know if there were 2, if there were 7, if there were 0. So x, or you don't necessarily have to use x. I always just kind of, that's by habit, I use x. So let's just use f for a number of field goals this time. So I don't know how many field goals were kicked. So number of field goals, or field goals kicked, or field goals scored, if each field goal is worth 3 points. So if I kick 6 field goals, or if I kick 2 field goals, what am I doing with that 3 points each time? Well, hopefully you know that means that I'm multiplying. So if I kick 2 field goals, I would take 2 times 3. If I kick 6 field goals, I would take 6 times 3. So because our number of field goals is our unknown, I know that that's like me saying the number of field goals and then times 3 for how many points you would get for each one, and then plus 5 more because that was in that expression as well. But an even better way to write this x times 3, like we learned yesterday, is just to switch these around and write 3x and then plus our 5 field goals. But remember, this defining a variable is extremely important for this translation. All right, example 3, the total pieces of candy split amongst 4 friends. So we got to figure out what our unknown is. I know that, again, let's just mix up our variables. So C is represented by, the reason I picked C is candy, because I don't know the total pieces of candy that we have. So we don't have the number of pieces of candy. Total candy, however you want to write it, but I don't know how much candy we started with. The only thing that I know is that I'm splitting it amongst 4 friends. So if I have a lot of candy and I'm splitting it amongst 4 friends, are we adding, subtracting, multiplying, or dividing here? Hopefully we know that split is designated by division. So you can write this as the number of candy, or how much total candy we have, divided by 4 friends, or you can write this as C over 4. Either one of these will work. All right, and then the last example is you eat 5 pieces of candy. Clearly I was obsessed with candy when I wrote these notes. For any number of days. Okay, so any number of days you eat 5 pieces. So what I'm going to do here is my unknown is how many days I'm actually eating it. So am I eating it for 1 day? Am I eating it for a million days? Am I eating it for 5 days? Am I eating it for 0 days? We don't know, so therefore that is our unknown. So D is going to be represented by the number of days. And then you eat 5, don't know why 5 came out there. Number of days, you eat 5 pieces of candy for any number of days. So for each day, if I ate it for 1 day, I would have 5 pieces. If I ate it for 3 days, I would have 5 and 5 and 5. So therefore, 5 times 3 gives us 15 pieces. So therefore, what I'm doing here is taking 5 times the number of days. But remember, I don't really necessarily need that multiplication sign. So right here, that could be represented by 5D. All right, so you go ahead and pause this video. I want you to answer these for you try problems. But before you give me these you try problems, I want you over to the right of this screen currently. So define a variable and translate each phrase into an algebraic expression. I want you to give me either a smiley face, meaning you totally get it right now, giving me like either like a middle face or a frowny face, meaning that yes, I'm totally with you, I understand how to define a variable, I understand how to write an expression, or a frowny face, meaning I need lots and lots and lots of practice. So make sure that you have that smiley face off to the right side, then go ahead and pause and you try these 4 questions. Alrighty, so let's take a look here. Number 1, 3 inches shorter than Catherine's height. Well, my unknown is I do not know Catherine's height, so therefore I use X, or you can use K, or you can use H. I don't care what you use, as long as you are very descriptive when you're writing this. So I wrote X is cat's height, so X minus 3. And then for number 2, half as many pieces of candy. I don't know why I forgot the S there. And therefore, I'm really liking candy here. There still. X is the total candy. And so you can either write it one of 2 ways. You can write half X, because I know half times X is me taking half of X. Or you could take X and you can divide it by 2. So either way there. You could also write this one over here as X divided by 2 if you would like. And then number 3, 5 less than double Tiffany's score. So if I'm doubling Tiffany, I'm multiplying it by 2. So Tiffany's score, which is S. I don't know why I wrote D there. That's silly. So I'm using S. So double Tiffany's score. And then take away 5 because it says 5 less than that. make sure that that 5 and like on number 1, that 3, they have to be at the end. Okay, I'm trying to like pretty much beat this into your head. If you see 5 less than or 3 less than or 20 million less than, that has to go at the end of your expression. And then the last one, 4, is the number of ounces in a water jug distributed evenly amongst 7 friends. So W is going to be represented by the total water ounces. So I don't know how much water we started with, but I know that I'm splitting it up amongst 7 friends. So I wrote W over S, or W with that divided by the number 7. Don't know where S came from. W divided by 7. My words. Whew. All right, so good luck on your problems tomorrow, and hopefully this all made sense to you. Good luck.